Good afternoon.
Hi, good afternoon. Welcome, everyone. Yeah, good afternoon. Let us go ahead and begin this lovely pre-calculus day. All right, let us begin with our check-in question, and it is March 1st. Woohoo! But I like this one. Are you organized or are you messy? What would you say? You can even think back to when you were in class, or you could think at your workspace, whatever that looks like when you're at home, if it's the kitchen table or your bed. Are you organized or messy? Go ahead and put that in the chat as we have here. And then we'll check out what you all are saying there. All right, let's see what we have. Okay, we got like a good balance. We have some organized, some messy, some both but messy. Messy depends on how I'm feeling. Both pretty organized, and we have both and messy. So it's like a balance. I feel like 50-50 here. I feel like I could be both, but 9 times out of 10, I am messy. Yeah, I would consider myself middle. Yeah, like I would say sometimes I'm like in the middle. Like I could keep things a certain way, but if it's too messy, it would bother me. If it's a little messy, it's fine. Um, as you could see, like, well, no, well, I don't know, like back here, like in this image right here of my classroom, or whatever, I purposely put messy binders. Like, if you could see the picture here, like they're slanted. I like that's too much work to actually go and fix those binders. So there's times in my classroom where I just let them be messy, but then I'd organize the tables, or so it would be a little bit of both, I guess, for me. In high school, I think I would say I was messy. I would be the type who didn't organize my papers, and just put all my papers in my backpack without the binders. So yeah, awesome. Thank you all for sharing. Let me see who we're missing. And again, y'all can correct me if I'm wrong, but I am missing Jalen. I'm missing Denise. I'm missing Jairel, CJ, Kyla, Risha. Am I missing Risha? Leon? I don't know if that's right. Again, if you're here, and then Sincere. Again, if you're actually here, sorry if I missed you. Trying to double check. Yeah, let me repeat that. So I am missing Jalen, Denise, Jairel, CJ, Kyla, Risha, Leon, and Sincere. All right, if that sounds good, I'm gonna hit submit. But please, if your friends are absent, um, please send them a text to come on into our very last class of calculus. Oh, we just got Risha though. Yay. Go ahead and update this. Welcome, welcome. There you go. All right, let us jump into our agenda. Thank you so much, everyone, for sharing. Here's our agenda. So, I just took attendance, and if you just came in, don't worry, I got you. Um, we're gonna go back into discussing the being in your groups and y'all working on the mini final. You got to start it last week, but we need more time on it. So we're going to continue that together. Again, the purpose of doing the Desmos together mini final is for you all to develop ideas, take screenshots to put on your own mini final submission. Remember, you're turning in your own separate copy of the mini final, and you can use evidence from your group work. You can use screenshots from your group work, but what you want to work on is justifying, right? So justify, make connections to the big ideas is what you want to do. Let me know if that's okay. And then I'm going to be giving feedback. So sometimes I pop into a group and give feedback, but not really to help. But generally, what happens is if I notice a misconception, I bring all groups back and we talk about it. So that might happen. Depends on what I see in groups, but again, I'm mostly an observer in your group, so I try not to like jump in or anything. I want you all to do the thinking and the load of the thinking. And at the end, we'll see if we have time for a checkout. Lately, we haven't been having time, but I'm hoping we do. Okay, so the mini final version. So the final version of the mini final I put as Wednesday, due on Wednesday. The reason for this is I do want to make sure I grade it and give enough time to return it to you so that you can make edits and give it back to me. But the final deadline for me taking in the mini finals, like so that it gets in the grade book, would be Friday. So Wednesday is just kind of like to get you feedback in the grading in. But of course, I'll be accepting work all this week. Let me know if anyone has questions about that, our agenda, or what's coming up, or about the mini final, or anything like that. Let me know. All right, yeah, cool. No questions. Let's go ahead and move on. So, oh, there might be a question. Let me see in the chat. Was the draft worth an actual grade? To be quite honest with you, no. I'm not making the draft worth a grade. What I did have the draft do for is I gave feedback. So for those of you who gave your draft, right, I wrote feedback to you. So that was why I wanted some drafts. So you turned it in and I gave you feedback. No, I did not attach a grade to it. So that's a good question. Let me know if there's any other questions though before I move on. Again, the draft is just so that you could give feedback. I don't want to like penalize people on the draft. That's the reason why I didn't attach a grade to it. All right. Let me know if there's any other questions. If not, let me remind you of the essential questions. These they're going to be very helpful for your mini final and how you try to answer your mini final. Okay. One of the questions that we were thinking about is how can I determine how fast an object is going at an exact instant? When we say exact instance, I'm asking you to think about like when you're driving a car and you're looking at that little speedometer, the thing that's telling you how fast you're going at that instant. That's what we mean. Like when you look down, oh, I'm going 30 miles an hour, and then you speed up, oh, I'm going 45 miles an hour now. So that's your exact instant speed. How do we do that though if we have a graph? Basically, we learned that you choose points that are very, very close to the point that you're interested in. We call that point of interest. And all you got to do is find the slope between those points. You can see right here in the image, you can see right here down here in this image. Now this right here, they're apart by 1 minute. Now this I would call an average rate of change because the points aren't close to each other. It wouldn't accurately represent exactly how fast the ball in this case was going at 2 seconds. But as I move that second point closer and closer to my first point, the point of interest, you're going to get a better approximation of the instant rate of change. I think we landed on negative 7.9. In this case, it was meters per second. But this would be your instant rate of change. This over here is just an average. That's a difference between the two. The next essential question is, and you might use this as well in your mini final when you justify, is how is the slope of a function connected to speed? Now, this is useful because we are trying to see if the teachers are speeding or not. How can slopes help us? So think about this. The steeper the slope, the faster the motion. Again, you can see that visually in the graph. As this slope, the red line got steeper and steeper, you could see that the speed increased. And this one would be, it increased in the negative direction. Its velocity increased, but its speed would be, if we took the absolute value of it, it would just make it positive. So the speed would have been 3 meters per second, 7.5 meters per second, and then lastly, 7.9 meters per second if I was to do speed for these at the bottom. Let me know if anyone has questions about this, just overview of the essential questions. Again, I know I've been always bringing this back, but it's super key. Okay, awesome. So I'm going to go ahead and jump into the teacher desmos. First off, to refresh you where groups left off, to also give some tips and get some feedback on answering number 1, actually, on your mini final. So let's see. So in a second, you're going to go into your groups. Once I put you in your groups, the same person who was the one logging in last time should log in this time. We are hoping those leads are still here though. If not, we're going to have to problem solve. But you were asked to first off together as a group, read the scenario. There's these math teachers and they're appearing before court and they're trying to dispute a speeding ticket that a cop gave them, a CHP officer. The officer is claiming that they're speeding because they drove over 75 miles per hour. But then these teachers are trying to protest that. I want to say that please don't use what the officer said or what the teacher says as evidence. The thing you need to use as evidence, and this is for everyone, is this. What we know, the evidence that we're given is that the teacher's motion followed this function. So that's what you're basing your work and evidence on, not like the teachers are actually guilty of speeding because that's what the CHP officer said. There we go, I'm done. Nope, you actually got to analyze this function. So that's my first tip there. Next off, in order to analyze a function, many groups went ahead and graphed their function. That is a perfect first step. Again, if your group didn't go ahead and graph your function, make sure that you do. In addition, take screenshots of this. You want to make sure that you include evidence in your own mini final so that you can analyze the graph and talk about the model that your group made. Cool. So then lastly, I definitely want to talk about, not lastly, but almost lastly, very quickly, how groups got the answers that they were getting. Sorry, let me anonymize this. There we go. Sorry. All right, so a majority of groups were getting, what I see here is 27.9 miles per hour. This group got a slightly different number, and we have a bunch of 27.9s. Now, in order for you to actually get proficient on your mini final, you need to explain what you did, right? So we need to know what are these groups doing and why? Where did they get this number? Why are they multiplying by 60? So for anyone who actually got this or who knows how they set this up, if you want to unmute or you could use the chat, can you kind of explain to us how we got 27.9? I want to first give that opportunity before me just taking over on it. Okay. And then Danny put, so who's right, like in that list? Well, we got to talk about it. So I want to know, for those who got the most repetitive answer, which is 27.9, how did you get that? And you can use the chat or you can unmute. I definitely just want some context because everyone in their own mini final, you're going to have to give us some context. Like, first, I did this and this because that's how you want to justify your stuff. Yes, this math work is going to be there, but you also want to make sure you justify and or make connections to a big idea. All right. So Danny, you said created a secant line from the first 9 minutes, collected the point. So that's the first step. So let me just pick someone's graph here. I'm in Charles's graph. So the first 9 minutes, I'm assuming you're saying you have to stop at 9 minutes here and divide it to get the average. So in order for me to actually stop precisely at 9 minutes, you know what I could do? Oh, okay, so it's actually 9 comma 4.185. Let me just put a point. 4.185. If you do that, that helps your point just stay. So that way you're not. Okay, cool. And then Danny's putting steps. Danny, can you tell us what's the first point though? You said draw a secant line for the first 9 minutes. So I know that they stopped driving after 9 minutes, but what would be the first point? Like, where do they start? Because I think
0.
0. Okay, perfect. Because another group I think started at 1, but you want to start your time at 0. So it starts at 0, 0. So I'm just going to add that here. And then Danny says that they drew a secant line. So let me go ahead and do that.
We didn't really do that, but we just imagined it.
Okay, just imagine. So this black line here, they just imagined it. Then it says divided to get the average. What do you mean by divided to get the average? How exactly?
4.185 by 9.
4.185 divided by 9. So is this connected to any big idea though? And you said this is to get the average.
Yeah, the average rate of change.
Average rate of change. Okay, so average rate of change. That is one of our big ideas. So yes, y'all can make your connections. Average rate of change. And I want to also remind everyone else. So it looks like Danny, you directly knew kind of how to set this up. But for everyone else, like if you needed some support on setting up this average rate of change portion, how we've been going over it is we label our points. For example, x1, y1, x2, y2. This is for additional supports. And how to get the same thing that Danny got right here. You do y2 minus y1 all over x2 minus x1. That's okay. For those about the draft, don't worry about the draft. As long as you get your final in, we're good. So y2 is going to be 4.185. You'll see we're going to get the same thing Danny got because your second point is just 0. So you're just minusing 0 each time. And then x2 is 9. So 9 minus 0. Because you minus 0, you're just going to get this very same thing that Danny got. Perfect. Okay, next, we got that set up. So now we understand where that came from. Okay, divided to get the average, then multiplied by 60 because we're looking for minutes and it asks for hours. So yes, so one thing you want to remind yourself, so this for everybody, if you go back, and I don't want to go back because I have all this writing, but if you go back to the original prompt, it says that formula that you were looking at, it's minutes per mile. So the units on this here function, I'm sorry, in this expression is minutes per mile. Min, let's just say min, and the bottom is miles. So that's minutes per miles. Danny says that we need to multiply by 60. But then, and then it says because it asks for an hour. I'm assuming it's because there's 60 minutes in an hour. Is that why?
Mm-hmm.
Okay, so we got 60 minutes in an hour. So we got 1 hour. Oh, I'm sorry. Shouldn't this be flipped there? Hold on. I messed up on this part, y'all. Be careful. Don't do a Miss Sedano. It's miles per minute. Because the top, your distance, miles. The bottom, it was for 9 minutes. Yeah, so be careful. Definitely correctly write your units. The reason why I noticed that there was an error is because if we have 60 minutes is equal to an hour, I know that the minutes will have to cancel out. So this is why we are going to multiply by 60. Again, if you write this out very nicely on your mini final, it shows very clearly that you know how to, convert and kind of multiply out. But yes, so if you divide these two, let me go ahead and use my phone to see if I'm going to get the same thing that these groups got. 4.185 divided by 9, I get 0.465 times 60. I also indeed get 27.9, and we're going to get miles per hour. 27.9 miles per hour. Don't forget your units. Boom. And then we have, do we need to do all that extra things? The only things you have to do is make sure you explain where did you get your numbers, what did you do, what big ideas. That's what you want to make sure you do. And you could also include screenshots. I wrote all these extra little steps because I wanted to make sure that I'm clear for those who have those in between questions. So not precisely, you don't have to write every single thing on here, but you do want to justify your work. Cool. Let me know if any group or any person has any questions about how these groups were getting this answer. So again, for that one group that had a -1 at the bottom, I think you started at 1 minute when you got to start at 0 minutes. Don't forget to multiply by 60 to convert your answers into miles per hour. All right, I'm gonna go ahead and clear my screen, but if you need to, take a screenshot in case you feel like you're gonna forget this. So I'll give you time for that. Take a screenshot. All right, I'm gonna go ahead and clear my screen, everyone, so we could move on so that y'all can get back into your groups. Oh my goodness. Yes, I will send the recording today. That is correct. Once it uploads, it might take like an hour. I try to send it as soon as it uploads. Okay, perfect. So that's how these groups are getting this, of course. So in your mini final, you want to make sure you justify. This is fine for the Desmos activity though, so you don't have to go back and add your justifications. For number 6, very quickly, many groups agreed that the steepest slope or the 2 points where the speed of the ant was the greatest or the steepest area was between A and B. So that is correct. One student thought point D. So the reason for that is you can imagine exactly kind of like how Danny mentioned, drawing a secant line. If you draw a secant line between A and B, you're going to notice that that line is the steepest than as if you were to connect these other lines. This is less steep and even less steep. So the steepest, I agree, is between the points A and B. So again, use that. It's going to help you out. Let me go ahead and clear this up. And I like it because that thing you mentioned, Danny, is exactly going to lead us into the next thing, steep slopes. All right. Now, I actually noticed a variety of different answers for here. So I definitely want to talk about that. So this is not talking about between 2 points. This is saying at which point is the instantaneous speed of the ant the greatest. So, and I put recall, the instant rate of change is the rate of change at an exact instance. Now, how are we to answer this with the tools that we have? So what you can do is you can still use a secant line, except the secant line is now at a point. Oh man, that one's pretty not good. Okay, let me do it again. So the secant line kind of just has to touch the point like so. I kind of wish I used a different color now. Let me do it again. There we go. So what you're doing is you're drawing little secant lines that's just touching the point. And from there, you could determine which point has the steepest slope. And that's going to tell you where the ant was traveling the fastest at an exact instant. So you all as groups can try to discuss where you think the steepest point is happening here. If you look here, so maybe y'all are gonna adjust your answers when you get back into your groups. or not. But if anyone has any ideas, feel free to put it in the chat. But like according to those secant lines, or these little lines, they're not exactly secant lines. I just drew like little lines at the point to kind of imagine what that instant rate of change line would look like. Which one would look the steepest? Then we have so B question mark. I mean, it looks like B, and let me like do this. It looks like B, like if I was to move away from the graph from the lines I drew, it does look like this line is the steepest. These and this are kind of close, but I feel like B would be the steepest. In addition, look at the graph itself. Look at how fast the graph shoots up at around B. Look how quickly it's doing that. I agree, A is indeed shooting up, but I feel like it's very much speeding up at around B. So I would agree that, I would agree, but y'all can discuss this further in your groups. All right, so for the next part, I'm not going to discuss it yet because I want you all to give it a try. Your goal after you're done with these slides together as a group is now apply what we know to determine the fastest speed that the teachers in their car, what was their fastest speed? Are they going to be able to disprove or not that CHP officer? Please use the tool that I linked here too in your groups. It will help you. All right, let me know if anyone has any questions before I start our groups. And there's a good question. Wait, how do we translate this to the final? So what do you mean by translate this? But it's very similar to like what we did last time. The same process. You know, you work in your groups, but then you still got to do your own mini final. And how you transfer it is basically you take screenshots of the evidence of your group work. But in the end, you're going to be responsible for justifying your own mini final, making connections to the big ideas and so forth. So that's how you're going to do your own mini final. That's a good question. Okay, I'm going to start to make the groups. And if you were in the wrong group or something, please let me know. I'm going to, try my best to put everyone back to where we were from Thursday. So give me a sec. I'll be here. Let me know if you all have any questions. Just turn off my camera. Again, if you're in the wrong group, please let me know. Some of these are looking kind of weird. Like it doesn't look like these are the right ones. And I'm basing it off also the what y'all submitted on the Desmos as well. So yeah, again, if you're in the wrong group, just let me know. I'll come by in your group and fix it. Okay, go ahead and check your groups, everyone. Again, come on back into the main group if you're in the wrong group. I'll be here to double check that. And I think, Rebecca, I need to assign you. So Rebecca, I know you were with Yaisa. I think it's breakout room 14. Go ahead and join your groups, everyone. I think everyone should be back to where they were last time. Let me know if you see the invite, y'all. Alex, Celia, Rosario, y'all. Oh, Rosario, I think is having issues. Alexander and Celia, are you? Oh, okay. How about Alexander? Are you having any trouble joining your group? Hey, Rosario.
Hi, it kicked me, the Zoom kicked me out.
Yeah, there's like 3 of you in here.
I know.
But it's okay. Do you see an invite for breakout number 13 in your new one?
Yeah.
Okay, try and join that one. I hope, yeah. Alex, are you able to join? Let me know if you're having issues. I can't really hear you. Okay. Hello, is everyone in the correct group here? I think so. This looks about right according to my notes. Are you all still getting yourself set up?
Uh, yeah, but we need a little help, I think.
How so? Oh, okay. Uh-oh. So, okay, so Tori's not home. So that was the original, the OG screen share, right? So I wonder, so is there someone else that can then screen share? And what you could do is just start where your group left off, and you don't have to redo any of that because you're still gonna get credit. So can someone else screen share? And that's how we can problem solve. I'll let you all decide. I'll come back. But yeah, decide who's gonna do the screen share and start where you all left off at.
Picture notes. Does anyone else have pictures of notes?
Hey group, sorry, just checking in. Does this group, does it look correct on who was here last time? You might just have new people, but like, I think I think it should be right. Let me know if this is, if anyone is actually supposed to be in a different group. Okay, cool. I'm gonna come back and check in, y'all. Excited to see what y'all come up with.
Okay.
Hey group, how's it going? Is everybody in the correct spot? Is the first thing.
Yeah,
Okay. Do we have a screen share here?
nah.
Okay, who was sharing screen
What?
last time?
We're all on phone, so I don't think we can really share screen like that because
Uh-oh.
they don't really show everything.
So is anyone able to join on their computer or laptop and I could just let them into the main room? And or I've seen actually people being able to screen share Desmos on their phone too. I've seen that being possible. So I don't know if y'all want to try that. Try and see how you all want to problem solve this. I'll come back, but I'm hoping you all figure out something. Try it on the phone. If not, if someone can log into their laptop and I'll let you in. Yeah, I'll check in a bit. Are y'all still figuring it out? How's it going? Okay, y'all still figuring it out. Yeah, whoever has a computer, just go ahead and log on in. Let me know and I'll go to the main room and let you in that way. That could work too. And or try and see if anyone can screen share from your phone. I've actually seen a group doing that. You log into the Desmos with your phone while on Zoom and you put screen share. That has been seen as a thing, but up to y'all what you decide. Uh, so like switch to a student who has a computer. Like, what do you mean, Danny? Sorry, I'm trying to figure out what you mean.
To just like switch one of us to with another person who has a computer in a different group.
Mm, let me try to see. So no one's home like by their computer. Is that like where it's?
Well, I do, but the computer is not really like good for like Zoom.
Your
So I
computer-
can only use it for work.
Okay, and is that the school one that they gave you, or is
Yeah,
that
the school one. The school ones are really janky. So I use my phone for Zoom and then the school one just for work.
okay? Well, gotta figure out some way to do it. So, let me see. I'm still popping in the groups to see what's happening. So I'll be back. So hold on a sec, and then, like I'm saying, try and see if anyone can do it from their phone. If it doesn't work, again, if anyone's at home with their laptop, just pop that open and I'll let you in. But I'll be back.
When there's hella people who want to come, you have to consider like who may need it.
Are you there, Mr. Nano?
Yeah, give me a second. I'm like, there's like some screen sharing issues, so I'll be right back. I know this
Okay.
asked for some help, so I'll be right back.
Okay.
Nice.
Okay, hey group. So did we try to do the screen share with a phone? Was that not working?
Nah, nobody's thing was working.
Okay, is nobody home? Like go on a laptop and just log into the Zoom?
I'm not able to do it, but I don't know if they're able to.
Okay, about Zion. I don't remember what you said, Brandon or Alex. Are you home?
Nah, I be using my phone all the time for zooming, like my work.
Because what was
I
that?
don't. I forget where I put my charger for my computer all the time, so I don't really
Yeah,
know where it
that's
is.
yeah, you want to let your advisor know. You definitely want your charger. And how about you, Zion? And or Alex. Like where are you two at? I'm gonna go ahead and start swapping you guys into a different group. So go ahead and just join that. Oops. Hello guys, do we still have the problem?
Yeah.
No, it's pretty tricky because the groups are very large. So try and see how you're gonna work this out, but I'm gonna try to split you guys up. That's the best we can do right now. All right, let's do this. Let's just see how this works out. My goodness. See if you get an invite.
I'll just talking. There's 8 people in here. I'm
Hello.
sorry.
So, well, sorry. Was this the group that asked for help last time?
Yeah.
So yes, I'd like you to please welcome your new group members. There's issues with screen sharing. So yes, it's gonna be a large group, but let's just work with it. Yeah, but what was the question?
What was the question? I don't know.
Or maybe y'all figured it out already?
Yeah.
Okay, awesome. So, I mean, you could also, anyone in this group could also just brief the new members here where y'all are at and what you finished discussing would be great.
We're basically just trying to figure out like what's the instantaneous speed, which is the greatest, I think. So we're just coming up with an answer for that.
Awesome, awesome. And if anyone from this new team has any input on that, feel free to jump on in. I'm going to be checking in our other group. I'll be back.
Wow.
Hey everyone, sorry. Was this the group that had the question?
Yeah,
Yeah.
you put more people in
Why
our
are
group.
there so many people here now?
Yeah, you put a lot of people in our group.
Yeah, so
Thought that was-
actually, there has been issue. Yeah, there's another large group as well. So there's issues where no one in the group is able to screen share. Yeah, so then this is the only solution we came up with so that they could still look at some group work. And yeah, so if you all can just brief them on where you all are at and then these new group members can also help as well with their expertise. So yeah, sorry about that. That was the only other solution to kind of work around this. But yeah.
Okay. We were just confused.
Yeah, like what is happening? Yeah, it's okay. Sorry, I was jumping into the other group and explaining the same thing. So yeah. So what was our question if we still have it?
Question number 8. We don't know how to do it.
So which one? We don't know how to do it.
Yeah, we need help.
Okay, what can you brief me on where you all are at? What did you try?
This one. What is the fastest speed that the car actually reached during its drive? You can go back to slide 4 as you try to determine this. Refer to your model and use your model to show us your evidence.
Wait, I got a question for you, Mr. Dano, that I think can also like answer this. Is this like the thing where we gotta draw the lines for each, like, since this is like a little squiggly line, do we just like draw a line on each squiggly line and see which one's the steepest? Is that what it's asking to do?
That sounds like an idea, Danny. I mean, that sounds good. Were you saying secant line? Or were you saying
What?
Were you saying secant or squiggly line? I wasn't.
Oh no, I said squiggly because you know it's every like it has like little, like you could draw the secant line on the squiggly. So when it goes up.
Okay, I'm not able to, I don't know what, yeah, it's hard for me to envision that, but I think that sounds right. You're saying draw these lines and see which one's the steepest. I think that sounds like a plan, right? Because the steeper the slope, the faster the what?
The faster the speed.
Yeah.
I mean, well, yeah.
Okay, so let's go back to that Desmos thing y'all were looking at for this group.
So we can screenshot this and then show this in answer 2.
Yeah, you can.
If it's right.
It. Yeah, you could, if it's right, screenshot it, and then your job will be to justify it.
Okay.
Justify what is the speed. So let's try to apply your idea. So what would you recommend they do? So in this tool, by the way, who's sharing? Is this? Oh, it's Yaisa. So you're able to move that purple line. So like Yaisa, can you show us how that line moves? Oh, okay, you could use this little bar there to kind of move it around. And we're concerned about the first 9 minutes, right? So we want to see the full 9 minutes of the teacher's drive. So maybe we could move the graph a little bit to the to cover more of the right side, if we're able to do that.
Wait, not that side, right?
Yeah, the other side. The only thing is how to.
It's just from 0 and to 9.
Yeah, it's just from 0 to 9. So, how does that? Let's see. I think you would have to scroll your bar to the side. And actually, I think you're going. Yeah.
To the to the right, please. To the right, please. Yeah, there you go.
But the only
A
problem.
little more.
Yeah, and the only thing is we only can see up to 5 minutes or 4 minutes here. So we want to just.
Yeah, Isa, can you like scroll it so like we can see 1 through 9? Like not yeah, there.
Yeah, there we go. So we could see a better representation. And okay, I'll let you all try to figure this out. I need to definitely check in the other group because it's a large one too. So I'll be back. All right, how's this group doing? Where are we at here?
I think we're checking our answer.
Okay.
And we're like struggling.
Okay, there's some struggling. Uh-oh, I can't, there's someone's voice was cutting off a little bit. Okay, so this is the one y'all are on?
Yes.
Okay, cool. So what have we tried? And we're trying to figure out what's the fastest speed that the teacher's car went, right? That's our goal. Did we implement the tool that's linked there?
Don't believe we have.
Okay, we have.
So I don't believe we have.
Oh, we don't. Okay, let's go ahead and click on there. It's a great tool. Basically, it's going to have your graph there. And there's also going to be a line that kind of helps you better see the slopes of the travel of the distance over time graph for the teachers. There we go. It's kind of loaded. You probably want to scroll a little bit to the side of the, or like kind of, what's it called? What's it called when you have to back away? There we go. There we go. So that we could see the full 9 minutes of the teacher's drive. There we go. Perfect. And that purple line, you can move it. So whoever's sharing their screen, is that Marcella?
Yeah.
Perfect. You can drag that purple line and you could see the different changing slopes. Yeah, take a look. See, it's more steep and then it gets kind of less steep. And then like as you move it, you're going to get different steepness of that line. How are y'all going to use that line to kind of figure out where the teachers were going the fastest and what that speed was? What are we going to look for here when it comes to the slope? And this is for anyone, if anyone has ideas. So we have this slope, we have our graph. How can we use this to kind of help us see where the teachers would be going the fastest? I went ahead and just put my question there in the chat. There's a good question there by AJ though. How do you put this line, like that purple line on Desmos? Well, basically, I don't think you can do that. In order for you to actually have access to this tool, what you got to do is just go into the Desmos and then you just go to slide. I think this is slide 8 on the Desmos, and just click that link or just save that link because it does it for you, but you can't really add it on Desmos.
It's too bad.
I know, right? It's a tool. So this tool, you could totally, how it says up here, Desmos calculator. I think if you just copy that link and open it in a separate window, you'll be able to play around with it. But you can use this tool and its evidence on your mini final.
Oh.
So definitely. So you could even take screenshots as well. But yeah, so how can we use that slope, the purple line, to see where the teachers are going the fastest? Like, does the slope, and I could narrow down the question. Would the slope have to be less steep, more steep, no steep? What do y'all think? If we want fast speed.
It could have to be steeper because you're traveling the farthest distance in the least amount of time.
That's right. So we want to find or locate an area or a segment in these 9 minutes that would, and that looks very steep. I see the point.
Yeah, right there.
That looks pretty good. Maybe we could zoom in around there and see at around, oh, and also if you look at the sidebar, it tells you 3.23. It's saying that X is 3.23. Or you could click on there and see what that coordinate would be. Okay, so that's a coordinate. All right, so in this group, first off, just making sure, like, does everyone see like why we kind of stopped there? And or if anyone has questions.
Looks like it's the steepest you're gonna get.
Okay, looks steep. Okay, now, if you were to try to figure out, and this is for your group to try to figure out this next, so definitely take a screenshot of this, and or maybe someone should write down that number. But your next step, I'm going to be popping into other groups, so I do want y'all to just struggle with this a bit. But now, what are we looking for? Are we looking for an average or instant rate of change? Is my first question.
Instant.
Okay, instant. So like an exact point in time where they might have been speeding. That's a good answer. Now then, what else do we need? We have 1 point. What else do we need to find the instant rate of change? And that would probably be a question for you all. So try to figure that out. So yes, we're going to be finding an instant rate of change. We've identified an area where the slope looks the steepest, but then now what? What else do we need to calculate or estimate their instant rate of change? And then AJ put another coordinate. He put 0, 0. Y'all can go ahead and discuss this. I'm gonna jump into the next group.
Wait, you're on your phone?
Yeah, I'm
Maybe,
on my phone.
Daniel.
That's
Maybe
why I'm
if
not
you just weren't on your
screen
phone.
sharing. I'm a screenshot. Also, the screenshots are so much better on phone too. So.
Oh shoot! Well, I don't like that.
Can you like move it like so that, like we can see this? Diego, it's not funny. You know, I'll just screenshot it. It's whatever, I guess.
Eddie coming in clutch with the screenshots.
You know what? No. I need to see the numbers. That's why I can't see the X value numbers.
You could have sung it before, Danny.
Okay, thank you. That's kind of what I was asking to like scroll. I don't know the directions to describe it. All I know is like I do it with my phone and I can't describe it, I guess.
So this would have been so easier if we were in person, if Rona wasn't a thing.
Right. It really would have. Really would have. Okay.
We have 10
Now
more tech issues on here than we would have if we had it in person.
Now go to 0.5. Now go to 0.5. You don't know before you do that, zoom into that. Zoom into it. Might as well just zoom into it.
It's weird that I have like
Daniel.
There you go. That's good. No, that was it.
What are you looking for, Danny?
Back. More accurate-ish photos. More
that
back,
was
please.
an accurate photo. I don't know what.
Zoom out a little more, please. Well, not a little bit, like a lot more. Like to show like 1 through 5. There you go.
Welcome, everyone. I'm trying to wait for everyone to come on back super fast so we could do a closing here. Welcome, welcome. Thank you so much for working together and, trying to figure things out. I know we had like large groups. Definitely that was like the only way to problem solve a little bit of the tech issues that we're going through. Hoping that we, fix a lot of that though. Again, please let your advisor know if you don't have a workable Chromebook or laptop or something, but yeah. Okay, Danny wants to continue some conversations on what your group was doing. Please do. But anyways, we do have some office hours that are coming up this week. Tomorrow is actually reserved for calc though. So my office hours for pre-calc Wednesday or Thursday are fine. So just so you know. Now, many groups ended off in good places. And before you go, I just wanted to share, or a group could share, I think both groups, actually it was one of the groups I was in today that was like identifying how we could find or kind of narrow down where the teachers were speeding. Let me just give an opportunity if anyone wants to kind of put that in the chat, but like, what can we do with this tool to figure out where in the 9 minutes of the teacher's drive, right, would they have been going the fastest? And thus we could figure out whether or not any point in their drive, if they were speeding. So let's see if anyone has any, like, how could we use this tool to do that? If you want to share with what you did in your group. Let me give you some time and then we could see.
Wait, so what did you say?
And I was about to type it in the chat, but how can we use this purple line tool that's in the Desmos, and you are free to use as evidence in your mini final? How can we use this tool to kind of figure out where the teacher's going the fastest? And then from there, kind of figure out whether or not at any point in their drive, they were speeding or not. So like, how is this tool going to help us is the question. And as you can see, you can play around with it.
Can you like send us like an email of this tool, please?
Yeah, the tool is also, I could totally do that. I mean, let's see if it works here too.
Because yeah, this would have been really helpful.
Yeah, it's also in your Desmos. Like you could just, like, if you go into the Desmos and just skip to where the tool's at, you could totally grab it there too. But if no one knows, wants to impart this knowledge, we could go ahead and have a closing. But
I can try if you want.
Yeah, that'll be great. So how can this tool help us before everyone leaves?
Okay, so what I thought from like your previous, like from earlier today when you like showed us the example of like just drawing the lines and comparing them. Well, you can move this purple tool and then I guess you can screenshot some of the places and then compare your screenshots and check which of the lines look steeper at which points. And the steeper the line looks, you can make a secant line out of it and then like do the math for it. And if the number is greater than 75, then that's how you know if they were speeding or not.
Okay, I got it. So you're saying like, it's like move this line around and start taking like little screenshots and then comparing where the line was steepest and then go on from there. And then you said make a secant line and then calculate. Awesome. And I know there was one group that identified a certain area. I don't know if that group wants to share like where you kind of zoned in. There was a specific point that you all were like, it's around here. Could also be worth sharing with everyone. If you remember, I don't remember as well. So I know you all found a good point.
Wait, can we don't have to share the screenshots. Can we just like say comparing everything?
Yes.
We
So-
found that this place looked the steepest, so we did the math there.
That's right. Yeah, you don't have to do
Okay.
all that. Yeah, you could just verbally describe and justify what you did. Now, I think one group, and again, y'all can correct me if I'm wrong, they zoomed in around like 3 point something. I don't remember which, but as you can see, the slope is very steep. You just want to verify that that's the steepest. And this group left off with, okay, we found an area where it's the steepest, but now what? So go ahead and think about that. So how are you going to find how fast the teachers were going at around this time? Think about that and try to apply that in your mini final. Oh, it's 3.23. So that's what the group, they settled on this area right here. But then their next step is, okay, now what do we do next? How can we find out how fast they were going at around this segment? So that's some imparting knowledge, y'all. I don't want to go over. I hope y'all have a great rest of your day. Go to advisory so you know what's happening tomorrow. Bye, everyone. Enjoy. Bye.
Bye.
Bye, y'all.
All right, see ya.
Bye. Bye.